This is a geometry that was discovered by Alan Green, which I wish to go through with you. It's on a book of poetry published in 1609, and as you can clearly see, there's a circle claimed that goes through, well, it's defined by two very large full stops, and I'll go through this in great detail with you, and then it intersects the ends of these lines, and then allegedly through this point, and then through this point at the bottom. Also, the tangents, the precise tangent at this point, will truncate this line, and the parallel chord to that tangent will truncate this line. Now, this line, this black line here, reflected perfectly so that we're just swapping the x and y coordinates around, will obviously necessarily bring a perfectly horizontal line here, and there's a line from here that well, on this I've defined it as going through the P, but in fact it needs to go to the sides of the P, to the serifs. I'll go through that now. Okay, let's explain what all these labels are. So the thing is that at each of these points, it is claimed that we have triangles with specific properties. This is a 3, 4, 5 Pythagorean, if you like, triangle. This triangle, this blue triangle, is defined such that this blue line forms a divine portion with this pink line. In other words, if you multiply the blue by root 5 plus 1 over 2, you get the pink. We call this a golden ratio. What about these other four numbers? So this is obviously pi, and we've got this to remarkable accuracy. And then we get into the controversial stuff, which is part of what I want to discuss with you. We've got allegedly e minus 1 and e as the, so this is the tangent value of this pi is the ratio of that to that. And likewise e minus 1 and e, right? And then there's an assertion that we have Brun's number. Now, I can't defend Brun's number, but I'm going to make a good attempt at defending E. I don't think this is quite as sensationalist as it might be made out to be. So let's, without further ado, go on to this morass of construction lines. All these lines have been generated mathematically just from these 2 points and the stuff that you saw on the other page. So let's first of all examine our highlighted circle, current vector line, and just see how close we are. So we don't want to be going through the ends. We want to be going through like a full stop's worth, or at least, you know, sort of the width of this line, if you like, through there. And indeed we are. That's, you know, I would regard that as a bullseye. This one is a little bit further out, and I'm going to argue that we need to shove this one along a little bit, a millimetre, but still pretty good. This is our alleged Brun triangle, but I'm going to argue that one away. And then we get to what is actually my favourite bit, which is what I was calling in my working group of one as the Aspley dot anomaly, because this dot isn't where it's supposed to be. It's supposed to be on this red line. I was trying to find excuses for it. Now, if we just pop over to this version with the unadulterated one, you'll see it's got a kind of a python on the top. So if we zoom in, why don't we just draw some straight lines on here? I did that quite honestly. put a point here, a point there, and a point there, and then jiggle them around until they look, as though they were nicely on here. It needs a bit more accuracy, but astonishingly, I just measured the angles on this just for a laugh, and they're both 51 and a bit, kind of, and I'm sure I don't need to tell you which famous pyramid has slopes of 51 and a bit. I mean, that is far too accurate, and I couldn't believe it. But I'm pretty damn convinced that this is meant to mean a pyramid, and as such, that point there is clear, in the zone of this red line here. I mean, it's very close within a pixel or two, and likewise we're very, very close to this 3, 4, 5. I'll come to the justifications of the triangles in a minute. So let's continue to our last dot, and oh look, that's absolutely sliced straight through the middle. So bullseye there. And our machine-generated phi triangle it's in the dots. It's about a millimeter to the left. So we need to move that dot, I would argue. So that's giving me a kind of a tolerance factor on because I claim that is wrong. Now from this point, there is a line defined that goes straight up initially to the P. It was defined to go through the back of the P, but I've moved it to exactly there, and as a result of doing that, it will cut through both serifs and the serif of that, and will intersect the center of this Cairo perfectly. We'll go through this letter D, which I'll come to in a moment, but it will also skim the serif of this very special T, and it will score an absolute bullseye on that full stop. So that's part of my argument of why I should put this on this side. Now, to continue with serif-ism, there is, you can see this interesting line here, this interesting point that appears to have some kind of triangle thing squared off on it. I need to look at that a bit closer, but the intersection of these three lines, this horizontal line and then these two, is astonishing. Again, it's within a pixel. This line, which is in fact the line from the Aspley Apex, as we should now call it, across to the left-hand side of the lower line, but miraculously it goes through, and this one is to the right-hand side of the upper line, and these two, for some reason, go straight through there. This line here will now, if it's drawn accurately, will just skim the serif on this T. Now this T is in fact supposed to be a bull. It doesn't look like that T at all, does it? This bit's similar but has been changed. It certainly doesn't look anything like that. And this bit is completely different, but it points up, and I always wonder why. I want it to point down. I want it to be a bull. Well, perhaps it points up in order that we can have some serif-ism, and you can argue whether or not that's nicely along the line of the back of that. Right, so I've got a little bit more serif-ism because I've drawn two vertical guidelines here. This one directly from the predicted phi point, and this one from roughly the center of where that full stop actually is. If we go directly vertically from there, we will hit the serif either way, either the edge of the serif or actually in the serif, but still not within there, to the side of it, and the letter I is in fact quite important, because in Latin they don't have a J, so you spell Jesus with an I. It's I for Jesus. So that further enhances that I, but also enhances my serif-ism argument. This angle now is over a degree. It's not enough to make up for I think it's 3 degrees that Westminster Abbey is out, but it's a bit more obviously at an angle. So let's just have a look at these 2 lines, which, as you can see, I've cheated on. If we look at the construction lines here, go out on this one. If you look at this line here, this lower line, it does start and end on the blue line. Right? Starts and ends in the blue, in that line, in this blue line here, but spends most of its life mucking around, being nowhere near it. And that makes it very difficult to look at if we're trying to find something precise. So, and the other one's not much better. It's not as bad, but it's still a mess, and so wanders around. So I've cheated, and I've filled the middle bits in just so that I can accentuate the horizontalness of this and the non-horizontalness of that. And the point about that is that I need this to be horizontal because I do not want to have to excuse Brun. I want to just be able to move this whole line up about 1 millimeter so that it needs to be centered on this upper guideline, because that's the one that goes straight through the pi, the E triangle. And likewise, this one needs to go through the E-1 triangle. So I actually, in order to make that perfect, or to show how far out it is, I'm going to need to pull this down a little bit. I mean, that's what that blue line is, so that's what, but I have to pull that down a wee bit, and I actually have to shove it up a little bit at this end. So that will reduce its non-horizontalness, but I would still argue that it is, certainly as drawn, not horizontal, and therefore suggestive of, if they're both just horizontally, so they're just horizontal lines, it would still leave us with nothing at all to define this lower line, because it's not equidistant from the centre or something. Why is it drawn there? But I'm claiming that I can get away with worrying about what this is. This is just where this line ends. So have we got E? We've got it to 2 significant figures. I mean, okay, 2.7 isn't too much. I've got to look at this more to work out how accurate I can blag that this is being measured. But I having discovered, read about the history of logs, and that in Christian Huygens, Nicholas Mercator, Isaac Newton, Jacob Bernoulli, and Gottfried Leibniz have all investigated this subject during the 17th century in some detail and contributed to the work of calculus and infinite sequences and stuff, but they're looking at the area under the hyperbola. That's all anybody thinks they're doing until Leonard Euler turns up and explains that these are exponents. Nobody, including Bernoulli, who actually came up with a function. So Bernoulli did find E. He found a function for calculating E, which he thought would then give him the compound interest of E-1. He did not understand that what we were talking about is e to the x multiplied by e to the y is equal to e to the x plus y, or any e. So is that it? Yes. I will just return at this point to this, just to give you a little bit of cryptography. This says by G, and if you care to search for Freemason's logo, you'll see that they've all got G in them, apart from the ones that have got a Khufu's triangle in it, Khufu's pyramid. This is a plus sign, you could argue, and I'm going to take two letters just because I want to. DE, that is, whilst it says neue, it doesn't mean neue, it means never. If it was a V, we'd have missed it. This is very, very precisely on there. So, just as a fact. So, DE, VE, and RE, de Vere, by God and de Vere. And if we zoom in on this, actually, let's take that one is better. This is an ox-shaped T. It's a bull, so we can call it an ox, and it says 4 and D, and this D for T thing is something that turns up in cryptography about this very regularly. I mean, in line, D for T isn't too big a deal, but having D for T in an acrostic, forming a crucifix with a D for T, is actually quite remarkable. So I'd just like to point out that this D is standing up a little bit. It's in the middle of this triangle here. Now the A and the T are standing up as well, but the D's noticeably higher than this N, and that's the point. But if we go back to this, which I've deliberately done like this, actually, Windows, that's the wrong one. This is a delta and this is a dot. I've got the wrong diagram here. There should be a red circle in here. File, open, presentation. There we go. And you can now see what we're talking about. So that is a delta and that is a dot, and I've got a D right in the middle of it. And delta dot is John Dee's signature. And it is believed, certainly by myself, that John Dee is responsible for this. And as you've seen, what we're talking about here is who wrote this stuff. So I've now got that yellow line on there, which will put it bang on that. I'd just like to show you that thing. The arguments about whether or not Wordsworth ever bothered putting a dash in the middle of his name. What intrigues me about this, apart from the fact that you don't put dashes in your name, is that it's clearly not out of a font set. I don't know what to make of it. I mean, it looks like it sort of fits in with this. So, yeah, you don't put dashes in your name, mate. Now, if you think that's crazy, you need to look on the next page, because the cryptography in the Cardano that has been solved as of 2016 is astonishing, but that's enough for now. I'll just go straight back to my thing and see if there's anything else that I forgot to tell you about. My assertions are that I've got an Aspley Apex with unnervingly similar angles actually to the pyramid, but it looks pyramid shaped. I am of the opinion that because it's said that Ortrud, in his edition of Napier's logarithms that's published less than 10 years after this, that he indirectly refers to E. Several people have come up with E, including particularly Bernoulli, and not noticed that it's not realised that it means exponents. But I don't think it's as bonkers as it might seem that D has stumbled across these two. It's a bit controversial, but that's the discussion. You know, have we got, on the grounds that we've got two values that are purported to be E, can we multiply the accuracies together and give ourselves more confidence in that? Other than that, isn't that an incredible discovery? That's that.